All right, so good afternoon, everyone. We're Group 19. Today we'll be presenting the results of our experiment where we tested paper airplanes of different sizes to see how their dimensions affect our flight performance. Next slide. All right, here's our table of contents and our introduction. All right, so the engineering goal of this project was to understand how changes in size influence distance, stability, and overall aerodynamics. So to achieve this, we use the same design for all sample airplanes. Next slide. The purpose of this project was to determine whether there is a direct correlation between airplane design and flight distance. Excuse me. Our response variable was the distance each plane traveled from the launch point, while our key constraints was our launch height and our controlled environment with minimal air resistance. By comparing how each performed under identical conditions, we can identify if size really matters. Next slide.
So for the experiment, we decided on having two factors, one for the paper size and another for the launch angle. And for these factors, we had four levels for the paper size, mini, small, medium, and large, and three for the angles, which were 0 degrees, 15 degrees, and 30 degrees. And then with two runs for each factor combination, this gives us a total of 24 runs. Next slide. And then for the project, there were three null and three alternative hypotheses. So for the null hypothesis, it's essentially just that the factors had no effect on flight distance. So the mean flight distance for the different angles would be the same, or the mean flight distance for the different paper sizes would be the same. And then for the interaction, the null hypothesis is just that there would not be an interaction between the two factors. And then for the alternative hypothesis, it's just that one of the group means is different from either plane size or launch angle. And then for the interaction effect, it's just that there is an interaction between the two factors. Next slide.
Experimental design.
So our materials consisted of four papers, one extra large, which was the 7 inches by 9 inches, and then below that was 5 inches by 7 inches, and then 6 inches by 6 inches, all the way to the extra mini, 3 inches by 3 inches. We also used a wooden launcher to keep consistency within the launches, a protractor, a measuring tape, and our table launch height, which you can see in the next slide, was held at 29 inches. Next slide.
Experimental process. First, we started out by making a mini paper airplane with its given instructions, and then we set the launcher at the edge of the table. We then loaded the paper airplane on the launcher, and using a protractor, we angled the launcher at its desired angle, 2 trials per angle. After we launched the paper airplane, we used a measuring tape to measure the horizontal distance from the edge of the table all the way to the farthest point of the paper airplane and recorded the data. We then repeated the steps for the rest of the airplane sizes. Here's an example of one of our trials.
For the data analysis, we grouped the data into the paper airplane size and the launching angle. We computed the mean of the two replications and did a cell noise check for all the data. Next slide. We ran several statistical tests with the key and most important one, the 2 ANOVA test, since it allows us with the p-value to decide on our null and alternative hypotheses. Next slide. Overall, the medium paper airplane traveled the furthest, followed by large, mini, and then small. Angle-wise, the angle did not have a significant effect on the travel distance horizontally at a significance level of 0.05. Next slide.
So coming into conclusion, next slide, we were able to determine the result of both of our null hypotheses. The first one being paper airplane size as being rejected, and the second one of being launch angles as not being rejected. So in this case, we did find that the size of the paper airplane does have a positive correlation with the flight distance, But then moving into the launch angles, we were not able to prove that the launch angle at which the plane is sent off at has any effect on the distance which it flies. It's also important to acknowledge the interaction between these two hypotheses. And with a critical value of 0.07, we are able to, comparing that to a 0.05 alpha, conclude that there is not enough evidence that there is significant interaction between the two hypotheses. Next slide. Moving into problems encountered, the first thing we noticed was that it was really hard to keep the paper airplanes moving in a straight line. So effectively what we did was we opened up the area under which we were launching the paper airplanes, but we also decided, instead of measuring the distance at which the planes flied on one single axis, we decided to take the measurements radially. So from the table to wherever the paper airplane landed, that was how we determined our distance, as opposed to operating on one, call it horizontal scale. The second problem we encountered was that the paper airplanes did experience damage throughout the launches. So it was a little more difficult to record multiple trials of one single size or one single angle, as we were somewhat limited with the amount of materials that we had. Next slide. And thank you.